Good day, my name is Victor. Today we are going to look at vector, and then let me try to introduce vector before we go to the first examples. What are vector quantities? Vector are physical quantities that have both magnitude and direction. For example, force. Force is an example of a vector quantity. When we talk about the magnitude of a force, 12 Newton or 50 Newton, there is a need for us to talk about the direction. In what direction is this force heading to? Another example of a vector quantity is displacement. It's an example of a vector quantity. And another part is scalar quantities. Scalar quantities are physical quantities that have magnitude but no direction. An example are electric potential. Electric potential is a scalar quantity. Also, distance is a scalar quantity. Let's look at the first example. An object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of the two forces and direction if, number one, the two forces act in the same direction. So if I have two forces acting on a particular object, let's say I have force P acting on this object, and I have force Q moving acting in the same direction on this object. So my resultant is equal to P plus Q. So if I have two forces acting on this object, I have the first force P, and then the first force which is 12 Newton, and the next one which is 5 Newton. So my resultant is the addition of the two forces acting on this object, which is 12 plus 5, and is equal to 17 Newton. And the direction is moving towards the eastward. 17 Newton eastward. And what is resultant force? Resultant force is a single force that acts on this object, which is equivalent to the two combined effects of these forces. So let's look at the second question. When the two forces are acting in opposite direction, if I have the object and then the first force is moving towards the east, force P, and the second force is moving towards the west, force Q. So my resultant is equal to P minus Q. So according to the question, we have one moving towards this direction, 12 Newton. And then we have the other force moving here, which is 5 Newton. So my resultant is equal to 12 minus 5, and is equal to 7 Newton. In what direction? They are moving toward the eastward direction. Because we see that the magnitude of the force here is 12 Newton, while this one is 5 Newton. Definitely the person pulling with 12 Newton is going to drag this object and the 5 Newton towards the same direction, which is the eastward direction. Let's look at question 2. The two are at an angle of 40 degrees to each other. The two are at an angle of 40 degrees to each other. 40 degrees happens to be an acute angle. What's an acute angle? An acute angle is an angle between 0 degree and 90 degree. An angle between 0 degree and 90 degree. We still remember our protractor like this, and then we'll see this is always 90 degree, and then we'll see. So from here to here is 90, from here to here is 90. So any angle between these is called our acute angle. So if I have 40 degree, that is almost half of this image. So I know I'm going to have something like this as my acute angle. So the first one is moving at 12 Newton, while the second one 5 Newton at an angle 40 degree. An angle 40 degree. According to parallelogram law of vectors, which says that if I have two forces represented by the adjacent sides of a parallelogram, this almost looks like a parallelogram. The adjacent sides of the parallelogram, because a parallelogram looks like this. So what we have here looks like the adjacent side of a parallelogram. So parallelogram law of vectors says that if I have two forces that is represented by the adjacent sides of the parallelogram, the resultant is always drawn from the diagonal of the point of intersection. This is where they intersect. So the resultant comes from the diagonal from the point of intersection. So by the time we complete this, we are going to have a parallelogram. As you can see here. So a parallelogram. Okay, good. A parallelogram. Why this is our resultant force? Our resultant force is the force 12 Newton. This is 12 Newton, the same thing as what I have here, which is 12 again. And this is my 5 Newton, which is the same thing as the opposite sides of the parallelogram. Because in the parallelogram, the adjacent sides are equal in length. So I can take this diagram out. If from here to here is 40 degrees, which is the angle between the two forces, then definitely this is also 40 degrees. And how do I get that? Corresponding angles or F angles, they happen to be equal. So in mathematics, the angle here is the same thing as the angle here. So what I have here almost looks like F. So from here to here is 40 degrees. Then from here to here is also what? 40 degrees. So if the sum of angle on the straight line is 180 degrees, 180 minus 40, so I'm going to get 140 degrees. Yeah, 140 degrees. So I have two triangles from this image. I can choose to pick the first one like this, where I'm going to have my 40 degree. I can choose to pick this one, which is I have my resultant, I have my 5 Newton, and I have the other one. So the angles between them here is 140 degrees. While this one is 12 Newton. So if I'm following this diagram, so the formula for calculating the resultant is going to conform with that of a cosine rule. And we know that cosine rule says that a squared equal to b squared plus c squared minus 2bc cos a, cos of this angle. So what I'm going to have here is going to be my resultant square equal to 5 squared plus 12 squared minus 2 multiplied by 5 times 12 cos, don't forget our angle is what we have here, 140. And now we get that. That's 180 minus 40 degrees. That's how we get that. 180 minus 40 degrees, which is our cos 140. So 5 multiplied by 5 squared will give you 25. 5, 12 times 12 give you 144. 144 plus 25, I will have 169 minus 2 times 5, I'm going to have 10. 10 multiplied by 12, I'm going to have 120 cos 140. 120 cos 140. We have equal to r squared. Cos 140 is going to give us negative 0.7660 multiplied by 120, 169 equal to r squared. Now, minus multiplied by minus, that's going to give us positive. 120 multiplied by 0.7660, we are going to have 91.93, approximately 91.93, plus 169. 169 plus 91.93, that one is going to give us 260.93. And by the time that our square moves to the other side, my r is equal to square root of 260.93, and the resultant force is going to be 16.15 Newton. Don't forget that we said the other time that we can either face these sides, and what we just did now is considering this part of the parallelogram, looking at this side. So that's why we have 140 here. Don't forget, I said this is 40 degrees, then this is also 40 degrees. Why? Corresponding angles, and the 180 minus 40, that will give you what? 140. Meanwhile, you can also look at this size again, such that I will have something like this, and I have something like this, and I can see my resultant. According to the question, both the two angles are acting at an angle 40 degrees to each other. You can see it here. 40 degrees to each other, while the horizontal is 5 Newton and the other side is 12 Newton. So if I have something like this, the formula for calculating the resultant becomes a square equal to b squared plus c squared plus 2bc cos a. You will discover that I've altered this formula. The reason is because there is actually a relationship between cos 140 and cos 40. Cos 140 is negative cos 40. So if I continue from here, you will see that my resultant r square equal to 5 square plus 12 square plus 2 times 5 times 12 cos 40. 5 times 5 will give us 25. 12 times 12 will give us 144. 144 plus 25, I'm going to have 169 plus 2 times 5, 10. 10 multiplied by 12, that's going to give me 120 cos 40. Though our cos 40 is 0.7660. Remember, our cos 140 is negative 0.7660. By the time you multiply with negative, we arrive at what? Positive. That means you have two options. You can either choose to use the angle directly. When you are doing that, you are going to use this formula, or you use this and 180 minus the angle, you are still going to get the same answer. So at this point, 120 multiplied by 0.7660, that's going to give us 91.93 plus 169. So 169 plus 91.93, actually you are still going to have 260.93, and then from there we have our resultant, which is 60.15 Newton. Don't forget parallelogram law of vectors. Anytime we have two sides that are representing adjacent sides to the parallelogram and we are asked to find the resultant is always the diagonal drawn from the common point of intersection. So the next question is find the direction. What is the direction? If you are find the resultant, how are we going to look for the direction? The direction is the angle which the resultant makes with the horizontal. Most of the time it's represented with alpha. Is the angle which the resultant makes with the horizontal. So if I bring that out, I'm going to have something like this, or the angle which the resultant makes with the horizontal. Actually, you see this is Z angles, alternate angles. This angle here is same thing as this angle here. So I can choose to use this triangle and make sure that I'm using this as my direction, or I come here and use this place as my direction. Either of the two, I'm still going to get the same answer. Using this as an example, so I'm going to have sine root A over sine A equal to B over sine B, and is equal to C over sine C. So that is 12 divided by sine of this angle, 12 over sine alpha equal to the other side. I can choose to name this A, and then A, B, and then I'll have C. So that is A over sine A, 12 over sine alpha, and then the next one is B, which is my small b, over sine 40 degree, and then we have C, which is the dot size that I have here, which is 5 Newton, over sine C. 5 Newton over sine C. So my B here is my resultant. And what's my resultant? 16.15. 16.15. So I have 16.15 here. So I will use this two formula. 12 over sine alpha is equal to 16.15 divided by sine 40 degree. Divided by sine 40 degree. Don't forget, I just named this triangle using A, B, C. This B, the side facing is small letter B. This A, the side facing is small letter A. While this angle C, the side facing this place is small letter C. And then I use the sign rule, which is that A over sine A for a triangle that is not right angle triangle. You always give me B over sine B, and it's equivalent to C over sine C. Don't forget that if we are using this triangle, what I'm going to have is quite going to be different if I'm following this other triangle. But we can continue from here and then we cross multiply. By the time we do that, we'll see that our sine alpha is equal to 12 multiplied by sine 40 divided by 16.15. 12 multiplied by our sine 40 is 0.6428 divided by 16.15. So by the time we do this, we are going to have 0.4776. 0.4776. Okay, 12 multiplied by 0.6428 divided by 16.15 is going to give us 0.4776. So it means our sine alpha is equal to 0.4776. Definitely our alpha equal to arc sine 0.4776. And when I do that, my alpha is going to give me 28.49. 28.49 degree. Actually, that is the direction. But in some question, they ask for the displacement. This is not specific. 28.49 degree. In what direction? Is it northward, southward, or eastward? Since we are dealing with vector quantity, so we have to be able to put direction to the 28.49. We are going to do it like this. So what we are considering is this. We are going to have our angle here. So this is our resultant, and then from there we have our angle from here to here, which is 28.49 degrees. So it's our resultant, and this is our 5 Newton. So we are going, this is northward, south, east, west. So angle from here to this other side will give me 90 degrees. So to get this side, the angle which the resultant makes with the vertical line, with the north-south line, gives me the direction. The angle which the resultant makes with the north-south line gives me the displacement I'm looking for. So I'm going to have 90 minus 28.49. 90 minus 28.49. That is 90.0 minus 28.49. So if I go one from here, put it here. That's 10. 10, 10, 9 minus 9 give me 0. This is 9. 9 minus 4 will give me 5 points. So I have 9 here. 9 minus 8 will give me 1. Then I have 8 here. 8 minus 2 give me 8 minus 2, 6. So my answer is 61.5. 61.5. So I'm going to have 61 northeast, 69, 61.5 degrees. 61.5 degrees. Northeast, 61.5 degree. Northeast 61.5 degree. And the last one is if the two forces are acting at an angle 125 degree to each other. Actually, 125 degree happens to be an obtuse angle. An obtuse angle is an angle that's between 90 degree and 180 degrees. So an angle between 90 degrees less or equal to theta, and my theta is less or equal to 180 degrees. An angle between this. And also obey again parallelogram law of vectors. So it is represented by the adjacent sides of a parallelogram. So that 125 from here to here is my 90. So definitely I'm going to have something like this. You have something like this. And I'll have the other sides. So from here to here is my 12 Newton. From here to here is my 5 Newton. And the angle between there is 125 degree. So my resultant is drawn from the point of intersection, so which will be something like so. What's my resultant? That's r squared equal to 12 squared plus 5 squared plus or minus either of the two, minus 2 times 12 times 5 cos 180 minus 125. 180 minus 125. Don't forget we said the other time you can also use 12 squared plus 5 squared plus 2 times 12 times 5 cos of this angle directly. You don't need to subtract. So if I do that, I'm going to have 12 times 12, 144 plus 25. That will give me 169 minus 120 cos 180 minus 125 is going to give me 55. 55 cos 55 degree is equal to my r squared. So 120 cos 55 degree, what's it going to give me? So I'm going to have 55 is going to give us 0.5735. 0.5735 multiplied by 120 minus 169. So this will give me 169 minus 120 multiplied by 0.5735. So 120 multiplied by 0.5735 is going to give me 68.83. 68.83 minus 169. Then I'm going to have my r squared. By the time I remove 68.83 from 169, I'm going to have 100, approximately 100.17 equal to my r squared. So it means my r is equal to square root of 100.17. That's going to give me 10 Newton. So it means my resultant force, if I have 12 Newton and 5 Newton acting at an angle 1.5 degree is going to give me 10 Newton. And the last part of this is to calculate the direction. Don't forget, we are going to look for the resultant and the direction for each cases. The resultant, the direction, the resultant, the direction, the resultant, the direction, also the resultant and the direction. And I said earlier when we were doing question 3 that the direction is the angle which the resultant makes with the horizontal, the angle which the resultant makes with the horizontal. You can do well to do that following what you have done in example 3. Snap what you have done and then you can send it to us on our WhatsApp platform. Thank you very much. See you in our next video.